In this section of notes, we're going to look at something called the counting principle, factorials, and permutations. So first up, we'll talk about the counting principle. You use the counting principle to figure out how many outcomes there are when you have a series of choices to make. So in this example, I'm going to a restaurant and I have a 3-course meal that I get, but I have a choice of 3 appetizers, then I have a choice of 4 main dishes, then I have a choice of 2 desserts. So one way you could figure out how many options you had is through brute force. You could make a tree diagram or a list, and you could come up with every combination of, I could have soup, pork, and cake, or I could have soup, pork, and a tart, or I can have soup, steak, and a cake, and so forth. I'd come up with every possible outcome, and it turns out there's 24 of them. Or I could use this idea called the counting principle, where I multiply the number of choices from each category. So 3 times 4 times 2, 3 appetizers, 4 main dishes, 2 desserts, gives me 24 options total. You might also see this in other places referred to as just the counting principle or the fundamental counting principle. They're all different names for the same concept. So next up, let's look at the idea of a permutation and a factorial. So permutations you want to use when you figure out how many different ways can you order something. So if order is important, you want to use something called a permutation. So let's say I had 5 pictures that I wanted to hang on my wall, and I wanted to make this ordering look pretty, make it aesthetically pleasing. So then in that case, the order that I put the picture frames up would matter. So my first picture frame, I'd have 5 choices for which one to put up. But once one's already in place, I'd only have 4 frames left to choose from for the second one that I put up. And then I'd only have 3 left and 2 left and then 1 left. So eventually I'd come up with 120 different ways that I could order the picture frames. Now there is a shortcut for this. Instead of doing 5 times 4 times 3 times 2 times 1, I can write 5 and then an exclamation point. That's the symbol for factorial, which just means that I'm picking a starting point and I'm multiplying down to 1. So every integer from 5 to 1 multiplied together. Next up, we want to look at what if I don't want to order everything. So what if I don't want to do 5 times 4 times 3 times 2 times 1, but I want to stop somewhere? Maybe I just want to do 5 times 4 times 3. So that would be where I come back and use this permutation a little bit more clearly. In that example that I just gave you, 5 times 4 times 3, the n would be the 5 because I'm starting with the 5. The k would be that I'm only picking 3 numbers, so that would be the 3 would be the k. Now there is a formula here. You don't really need to worry about it too much because it's going to be easier typically just to set up the multiplication problem. And then there's actually also going to be a separate video later where you learn how to do this on your calculator. One thing just to note though is that 0 factorial doesn't make a whole lot of sense. So if I say start at 0 and count down to 1, that wouldn't really make any sense. So it comes up a lot and we've just given it a definition, and we're going to say 0 factorial is going to be equal to 1. So before you move on, there's going to be 2 calculator videos. Make sure you watch both. There's one on how to do factorials in your calculator and one on how to do permutations in your calculator. After that, make sure you try the practice problems.